Newton's rings. Newton's rings is a phenomenon in which interference pattern is created by the reflection of light between two surfaces, a spherical surface and an adjacent touching flat surface. It is named after Isaac Newton, who investigated the effect in 1666. When a parallel beam of monochromatic light incident normally on a combination of a plane of convex lens and a glass plate, a part of each incident ray is reflected from the lower surface of the lens and part after refraction through the air film between the lens and the plate is reflected back from the plane surface. These two reflected rays are coherent and are having distinct path difference between each other, depending on the thickness of air film formed between the lens and the glass plate. By applying conditions of cosine law, depending on the optical path difference values, we will get the condition for dark and bright bands. The locus of all the points under the same thickness of the air film will fall under a circle, and we can see the alternate dark and bright rings. Apparatus. A monochromatic source sodium vapor lamp, a combination of plain convex lens and a plain glass plate, and it's a plain glass plate and convex lens arrangement. So we have to put that plain glass plate on the ring, and then over the plain glass plate we put the plain convex lens, and using the screw we fix the setup, and we're having a reflector at a 45-degree angle to get the normal incidence, and a traveling microscope. Procedure. Turn on the sodium lamp. Place the plano convex lens on the top of the glass plate with the curved surface in contact with the glass plate. Place the arrangement beneath the 45-degree inclined reflector placed under a traveling microscope. The reflector at a 45-degree inclination direct the light normal to the optical system. Focus a traveling microscope to observe the dark and bright circular fringes. Fix the vertical crosswires of the microscope at the 20th bright ring at the leftmost end and record the reading on the horizontal scale. Repeat this measurement for microscopic movement from left to right and evaluate the diameter of different rings. Calculations. The traveling microscope, there is a main scale and a vernier scale. The main scale has 20 division between 1 centimeter reading, and vernier scale has total 50 divisions. So the least count of the microscope is equal to 1 main scale reading divided by total division in the vernier scale. So here, so we can write 1 main scale reading is equal to 1 by 20, because the main scale has 20 division between 1 centimeter reading, and the vernier scale has total 50 division. So the total number of total division in the vernier scale is 50. So the least count is 1 by 20 divided by 50, that is equal to 0.05 divided by 50, that is equal to 0.001 centimeter. The microscope reading is equal to main scale reading plus product of vernier scale reading and least count. Take the readings of main scale just before the 0th position of vernier scale. Only one line of the vernier scale coincides with the main scale. Take the readings of that point from the vernier scale, that is the total number of vernier scale division up to that point. So that we can write, in this case we can write MSR is equal to 6 and VSR is around 24. As we can see in the figure, the 24th position or the 24th division or 24th division line coincide with the main scale line. So VSR is equal to 24. Okay, so and we have the least count that is equal to 0.001. So the microscope reading in this case or in this scale can be calculated as 6 plus product of VSR into LC, that is 24 into 0.001. So that is equal to 6.024 centimeter. To find the diameter of the ring, the microscopic readings are taken from the 20th bright ring in the left side, and the measurements continues towards the right side, keeping a separation value k is equal to 5. So you need to take the measurement at n plus 20, n plus 15, n plus 10, n plus 5, n towards the center from the left, and it should continue for n plus 5, n plus 10, n plus 15, n plus 20 towards the right, keeping a k value equal to 5. So we can find the diameter of the ring as well as the value of dn plus k square minus dn square.